So, how in the world do we make sense of the overwhelming amount of data out there? Today, we're going to break down the powerful process of turning all that digital chaos into clear, useful insights. This is data science, demystified. Let's dive in. To really get a handle on the scale of this challenge, you have to start with this number. It's estimated that over 80%, yeah, 80, of the data we generate today is unstructured. That is a staggering amount of the world's information that just doesn't fit into a neat, tidy box. It's a jumble. And that leads us to the central question we're tackling today. With all this messy, unstructured stuff out there, emails, social media posts, videos, you name it, how do we actually find the valuable signals hidden in all that noise? How do we find the meaning? Well, the very first step is learning how to sort it all out. Before we can even think about analyzing data, we need to understand what we're looking at. And that means learning to recognize the different fundamental forms that data can take. This slide really just nails the fundamental divide. On one side, you've got your structured data. It's organized, it's predictable, it fits perfectly into the rows and columns of a spreadsheet. But on the other side, you've got unstructured data. No format, no rules. Think of it like the difference between a perfectly cataloged library and just a giant unsorted pile of books, newspapers, and scribbled notes. But it doesn't stop there. Beyond that basic split, data science deals with a whole spectrum of data types. We're talking about the natural language we speak, information that's automatically generated by machines, and even data that describes really complex relationships. So let's zoom in on a few of these. First up is graph-based data. Now, this is not about your typical bar graphs or pie charts. So what is it? Well, it's an incredibly powerful way to map out relationships. Just imagine a bunch of dots, which we call nodes, and lines connecting them, which we call edges. The nodes are the things, and the edges show how they interact. And this is a perfect way to picture it. Think about a social network. An influencer is a node. Every single one of their followers is another node. And that follow button they clicked, that's the edge connecting them. With this simple idea, you can suddenly map out entire networks of influence and connection. It's pretty cool. Next up, we have machine-generated data. This is all the information that's created automatically by systems, without any direct human input. We're talking about things like the log files from a web server that track every single click, or that constant stream of temperature data from your smart thermostat. It's like a definitive second-by-second record of activity. And that flows right into our next one, streaming data. This is data that's in constant motion. It's generated continuously, usually in tiny little packets, from thousands of sources all at once. Just picture the endless flow of posts on social media or the real-time data from financial trading floors. It's literally a digital waterfall of information. Okay, so we know how to categorize all this data, but how do we actually use it, right? This brings us to the absolute core of data science, the process that methodically turns that raw information into real-world results. And here it is. This is the blueprint that data scientists follow. It's a systematic journey that takes us from a messy pile of data all the way to a valuable, actionable insight. It's a methodical approach that brings order to all that chaos. This whole process can really be broken down into 5 core steps: collection, cleaning, something called exploratory analysis, then model building, and finally, deployment. Each step is absolutely crucial, and each one builds directly on the one before it. So it all starts with collection. You can't analyze what you don't have, right? This first vital phase might mean running surveys to create new data, or it could be about scraping existing information from websites and other public sources to get your hands on the raw material. Next comes one of the most important, and let me tell you, often the most time-consuming steps: cleaning. We already know that real-world data is messy. It's full of errors, missing pieces, weird inconsistencies. This step is all about methodically scrubbing it clean, fixing typos, dealing with missing values, and getting it all into a structured format. Because, quality in, quality out. All right, now we get to the fun part, the detective work. This is called Exploratory Data Analysis, or EDA. This is where you really start digging into that nice, clean data. You're making charts, you're searching for hidden patterns, correlations, and any strange outliers. You're basically asking the data, okay, what interesting stories have you got for me? Once you've got a feel for the data story, you move on to building a model. Here, you're using powerful machine learning algorithms, which is really just a fancy way of saying you're teaching computers to find patterns themselves, to build a model that can systematically spot complex relationships that a human well, we might easily miss. And finally, deployment. Because what good is an amazing model if it just sits on a computer, right? This final step is all about putting that finished model to work in a real-world application, like a recommendation engine on a shopping site or a fraud detection system at a bank, and then constantly monitoring its performance to make sure it's actually delivering real value. So, when you put it all together, what's the big takeaway from this whole journey from chaos to clarity? See, data science isn't just about fancy algorithms or giant computers. At its heart, it's a disciplined process. It gives us a reliable method to take that overwhelming, chaotic mess of raw data and transform it into clear, understandable, and actionable insights that can drive real decisions. And that leaves us with a final thought. We are generating more data today, every second, than ever before in human history. By sorting these signals and following this process, we're starting to find answers to questions we never even knew we should be asking. So the real question is, what's the next big mystery we're going to solve with data?